Hi, this is Mr. Manley, and in this video we're going to take a look at a trigonometric proof, which is going to look like the two-column proof that you did in geometry. There are just some formatting issues that you need to adhere to for me. So the first thing is that the steps will be numbered, as in a two-column proof, and then outside of that, it really should look exactly like it did when you simplified it. So I'm going to take the expression down and make that my first step. And this is another formative element, is that the first step will always be given. And so your first step will always be either you're selecting the left side of the equation or you are selecting the right side. So this needs to be your first step, or this needs to be the first step. And there will never be an equal sign in any of the statements for the step. So you're just taking an expression, and there will not be an equal sign anywhere in the step. So you've chosen a side, and now you are going to operate upon that expression until you get it to look like what you're trying to prove. So the next step here might be this. I'm going to take the secant and multiply by 1 plus secant t minus tangent t times tangent t, and then all of that is over tangent t times 1 plus secant t. And that is, what did we do there? I mean, I would say we subtracted with a common denominator. And that's how I would describe that second step. The third step here, I'm going to go ahead and expand and simplify. So I'm going to have, well, there won't be anything to simplify, so I'm just going to expand this. So secant t plus secant squared t minus tangent squared t over the tangent t, 1 plus secant t. And you can see that this is just no different than when we simplified the expression. And then my reason here, what did I do? I multiplied. Really, that's all I did. I multiplied the first term, I multiplied this term out, and I multiplied that term. And that's all we did. So that'll be my statement of reason for this step. Okay, moving along to step 4. In this case, we've got secant squared t minus tangent squared t, which will simplify. To 1 plus secant t over tangent t times 1 plus secant t. All right, and now we see, well, first of all, just understand we said that is equal to 1, and that's coming from a Pythagorean identity. And I think that's all we did in that step, right? So we'll label that as a Pythagorean identity. And then step 5 will be 1 over tangent t, because we are dividing and canceling these, right? So that'll be division. And step 6 is cotangent t. And we're finished. And that was accomplished with reciprocal identity. And we've completed the proof. So you see it looks exactly like simplifying. I am adding the numbers, so I am numbering the steps. There's never, an equal sign is never introduced in any step. So if you do this and you follow my instructions here, you'll never have this problem that some students have of they use an equal sign and they set up a step and then they somehow use a property of equality within the proof. But there should never be a property of equality used, and it should not be a problem because there should never be an equal sign. So that is, I think, all the information that you need to get rolling with doing trigonometric proofs.